Hi, I'm Scott Pigg with Seventh Wave, and I'm here today to talk to you about a project that we recently completed about savings opportunities from proper installation and maintenance of central air conditioners, furnaces, and heat pumps in Minnesota. Now, this is work that was sponsored by the Minnesota Conservation Applied Research and Development Program with some assistance from Minnesota Power. And our main objective was to look at the extent of savings opportunities for proper installation and maintenance of this equipment and look for ways that Minnesota utility programs could be more effective in addressing those opportunities. So our research involved, first and foremost, before and after testing of tune-ups for more than 100 air conditioners, furnaces, and heat pumps in the state. We also did a survey of more than 700 Minnesota homeowners, and we did a number of interviews with equipment distributors and heating and cooling equipment contractors in the state. So what did we find? Let's start with air conditioners because that's where most of the interesting results came from. So about 80% of Minnesota households have a central air conditioner, and that's more than 1.5 million units across the state. When we tested a random sample of these air conditioners, we found some opportunity to improve the efficiency of the unit in 9 out of every 10 systems. Now we found in some cases this was as simple as like changing a filter or cleaning the outdoor coils on the outdoor portion of the air conditioner, but the two biggest issues that we found were adjusting refrigerant charge and system airflow. So let's talk about refrigerant charge. Some people don't know this, but when you install a central air conditioner, the amount of refrigerant in the system needs to be adjusted in every case. And that's because a central air conditioner has two parts, an outdoor unit and an indoor unit, and the distance between those two parts varies from home to home. So proper installation involves doing some specific tests to make sure that the amount of refrigerant in the system is right. And in some cases, this is not done at all or is done in an improper manner. And once that refrigerant charge is set in the system, the odds are that that air conditioner is just going to operate with improper refrigerant charge for the remainder of its life. On airflow, and here we're talking about airflow across the indoor coil and through the ductwork, air conditioners and heat pumps are designed to operate within a certain range of airflow, and if that airflow is not correct, it can lead to problems. And we found a significant incidence of systems in Minnesota where airflow was not within the proper range. In the majority of cases, it was airflow that was too high, and that's because Minnesota is a cold climate, and so you tend to have large, high-capacity furnaces that are paired up with smaller capacity air conditioners. And that's just a situation that if an installer doesn't take the time to measure and adjust airflow, on average you will end up with airflow that's too high. And airflow that's too high creates two problems. First, it's an efficiency issue because you have a blower that's drawing more electricity than it needs to, and the air conditioner actually has to work a bit harder to get rid of the blower motor heat. And second, high airflow can be a comfort problem because it compromises the ability of the system to remove moisture and reduce humidity in the home. So what we found with refrigerant charge and airflow is that most of the time these things are not set exactly correctly, but they're not that far off. And when we fix these issues, on average we get maybe a 5 to 10% improvement in efficiency. So the system works just fine, and no one would notice that it's not operating at its optimal efficiency, but it is in fact running just a little bit less efficient than it should. However, about 1 in 6 systems has a much bigger issue, and if you correct, it's usually an undercharged refrigerant situation. If you correct that, you'll see 25% savings or more. And in a few cases, among our 100 homes that we tested, we actually doubled the efficiency of the unit by fixing an existing problem. So let's look at furnaces for a second. So unlike air conditioners, furnaces are much easier to install, and there are fewer adjustments that need to be made. And what we found, in fact, was that most furnaces that we tested in Minnesota homes were producing heat at about their rated efficiency, and there was little that we needed to adjust. Now, for both air conditioners and furnaces, when we talk to homeowners, what we find is that installation quality and installation defects are not on their radar at all. What people think about when they're thinking about buying a new furnace or air conditioner is first price and second installer reputation. And if you ask them about installation quality, what they're likely to think of is, does the installer sweep the floor after the thing has been installed? So this is definitely not a customer-driven opportunity. So a number of Minnesota utilities have installation standards for especially new high-efficiency air conditioners that they offer incentives on, and that's a great thing. But it still leaves a lot of systems that are either new standard efficiency systems or older existing systems that are operating at less than their rated efficiency and could offer some savings. Now, there are some utility incentives for addressing these systems, but they tend to be fairly low incentive amounts, and in the absence of customer demand, there's just not a lot of uptake for these programs. To realize full savings potential from better installation practices, you need to make it as painless as possible on the part of the installers and service technicians so that they can get it right, but without the hassle of having to fill out lengthy rebate forms. So there might be a path forward here in terms of new cloud-connected diagnostic equipment that could automatically document good installation practices as well as where the service was performed, so that heating contractors and cooling contractors could get an incentive automatically just by using this equipment and having it interface with a utility incentive program. If you're interested in this topic, we have a more detailed technical report that you can look at. We also have 2 other videos, one that's oriented towards homeowners about what to look for when installing a new furnace or air conditioner, and another one that's for heating and cooling contractors regarding how to measure airflow. So thanks for watching.